Welcome to the complete guide to building a simple 3-channel delta wing RC airplane. This video will thoroughly detail the construction from start to finish. We will first begin with gathering all the materials needed for construction. The materials will include Depron foam, EPP foam, carbon fiber strips and rods, balsa, music wire, magnets, control horns, and a few screws for mounting the motor. We will also need electronics, which will include a receiver with 3 or more channels, a 460 mAh 2-cell battery, a 2900 kV motor, a 10 amp ESC, 2 5-gram servos, and all the necessary connectors. We will also need hinge tape, a 6x4.5 3-bladed prop, masking tape, thread locker, adhesive back hook and loop fastener strips, and white polyurethane glue. The minimum tools required will be a hobby knife, screwdriver, pliers, ruler, disposable brush, fine tip marker, and a handsaw. Now let's get to building. The first step will consist of cutting out the foam sections. We will start with the wing. We will make the layout shown in violet on the 1/8" foam board using the marker and ruler. The layout will ensure we make the plane symmetrical. The wing is 17 inches wide and 11.5 inches long. The width of the nose is 3.25 inches wide by 3.5 inches long. Don't forget to include the center line. We will make marks at 1.25 and 1.5 inches from the end of the nose section. This will help guide us in freehand drawing the nose curve. Do your best to make the nose symmetrical. We will now include the layout points to outline the wing section. To cut out the sections, use as thin of a blade as you can find. Cut with the blade at a very small angle as shown here. This will prevent tearing from the foam as you cut. You will have more control of the knife if you draw towards yourself. Next will be the vertical stabilizers. The stabilizers are 3 by 3.25 inches. The top crop will be about 1 inch. You can cut out identical shapes faster and easier if you make the outline with them together. It is more important that they are identical than an exact size. For this reason, it's good to trace the second part around the first. The tail sections are 2.75 by 8.4 inches. The cutout is to give clearance for the prop. This section is best made by laying out the square and then cutting out the clearance. Use the first to act as a stencil to trace out the second. The fuselage is 3.25 by 11.5 inches. Cut out a strip of foam of sufficient length that is 3.25 inches wide. Then butt it up to the wing. Center it and trace the nose of the wing onto the fuselage piece. Then cut away the excess. The elevons are 5.75 by 1.625 inches. As before, use the first to trace out the second. With all the foam pieces cut out, use coarse sandpaper, such as 60 to 100 grit, to round off the edges. You can also use a knife to do the same, but it's trickier. Use a small piece of sandpaper to get into the inside of the tail section. The center spar will be made from 1/4 inch by 1/8 inch balsa. It will need to be cut 17 inches long. The motor mounts will need to be cut by 1/4 by 3/8 inch balsa. The top mount is 2 inches and the bottom will be 3 inches. Measure a 1/2 inch back from one edge and mark. From the tall side of the balsa, cut an angle from the mark to one edge of the wedge. Do this to both pieces. The center is cut from 1/2 by 1/4 balsa and will be 3.25 inches long. Cut with a small taper to the inside. We will now begin with the assembly. Take the wing section and the spar and make a dry fit. The spar and wing should match in width. Take water and disposable brush and wet the narrow sides of the spar. Polyurethane glue requires moisture to cure properly, so always wet one surface when gluing major components. Add the glue to one of the narrow sides. The glue should cover the full length, but use very little as it will expand. Mate the glued side of the spar with the wing. Apply a piece of masking tape across the joint. Make sure the tape is flush with the edge of the spar and doesn't go over it. Flip the wing over and apply the tape to the other side. Now we will add the tail sections. The cutouts go in the middle, and the edges of the tail pieces should be flush with the outside of the spar. Apply glue to the foam side and butt up to the spar. Wipe away excess glue and water with a paper towel. Apply tape to both sides like we did with the wing section. Use weights if needed to ensure that it all stays perfectly flat. You will need to leave it be for at least 20 minutes for the glue to cure. Once the glue is cured, remove the masking tape, but be careful not to damage the foam. Next, we will glue the fuselage to the wing. Use a saw or blade to gently roughen the wing section where the fuselage will go. Apply water to the wing side and glue to the fuselage side. Use thin passes of glue rather than large blobs. Carefully apply the fuselage using a subtle massage motion to spread the glue. Place weights until the glue dries. We will apply the center spar and motor mounts at this time. First, we will wet and apply water and glue to the center spar. It will be placed directly behind the fuselage with the taper pointed away. You can use a paper towel to wipe away excess glue and water. Next, we will glue the shorter motor mount wedge to the top. The two spars of the motor mounts should be flush with one another. Once the motor mount is in position, carefully tape it into place. Once the motor mount is in position, carefully tape it into place. Place the longer motor mount wedge on the bottom. It is critical that all the mounts and spars are flush and even with each other. Tape and check again for flushness. Apply tape to the small spar as well. Now we will outline the wing and the tail with 0.5 by 3 mm carbon fiber strips. These measurements are approximate. The exact lengths are best cut to fit. If you pre-cut the pieces, allow for a small amount to be trimmed. Place the pieces along each side and trim them to fit. A fine-tooth saw works best. Some are concerned with the dust that carbon fiber produces. If you are, then wear a dust mask during the cutting. If the saw you use causes the ends to fray, then apply tape to the strips where you want to make the cut. The nose is tricky, so be sure to wrap around and mark right at the center while holding the strip firmly against the foam. Apply glue to each strip and apply the tape lengthwise to cover the joints. The tape keeps the foam from expanding too much. When gluing the nose sections, you will need to glue both sides and bind them tightly at the same time. The last two strips are applied to the tail. This example has the strips cut flush with the tail, but you can leave them longer to give protection to the elevons. A tip to make your glue last longer is by pushing out all the air before putting the cap back on. The carbon fiber adds a significant amount of rigidity and crash protection to the craft while adding very little weight. Balsa or bass could be substituted, but with decreased performance. We will now install some carbon fiber on the bottom of the wing. Cut out 6 strips at 3.5 inches in length. Place them 2.25 inches away from the inside edge of the tail. They should be flush with the trailing edge. Now we will inlay carbon fiber into the wing. The strips will be cut into 2 5.5 and 1 9.5 inch long pieces. The rod is cut at 11.375 inches. 1/8 inch deep slits are cut into the underside at the center line from the tip of the nose to the motor mount. Check for a dry fit first before applying glue. Once you have a good fit, apply the glue, insert the strip, and cover with tape. Cut a V-shaped slit laterally on the underside at the point where the rod just barely touches the inside of the wing strips. You will need to notch out the center strip where it crosses. Glue into place and secure with tape. The nose strips need to meet at the center strip. Their placement is approximate but should be symmetrical to each other, so measure equal distances. The cuts for these strips will go through the wing, so make sure that you wipe away all the excess. We will now go back to the top of the wing. Two small 1.5-inch strips are placed on either side of the top motor mount wedge. The 3.5-inch strips will be cut before being placed on the inside edge of the tail, and the other two are placed 1.5 inches from the outer edge. The vertical stabilizers are placed approximately a quarter inch from the edge of the tail. Two pieces of carbon rod are used to reinforce the stabilizers. They should be at a 45-degree angle to both surfaces. After securing the inside strips, we will remove any glue or other materials so we have a flat surface to mount the stabilizers. The rear edge should be flush with the trailing edge of the tail. A hole is punched through and a rod fed through into the tail. The rod should hang out 1/8 of an inch from both sides. Be sure that both ends are thoroughly glued into place. The stabilizer should be square with the tail. The other two carbon strips should be placed against where the rod pierces through the tail so it can help support the stress. We will install the servos 4 inches from center. To achieve the lightest and strongest construction, the servos will be glued into place. Remove the mounting tab on the opposite side of the output. If you cut away too much, place tape over the hole. Trace around the servo with the modified side against the spar, and then cut out the shape. Cut out a piece of foam that is about an 1/8 inch wider than the servo. Cut them about 3/4 of an inch long and double them up. You can pre-sand them now if you want. These will be used to increase the gluing area of the servo. Apply glue to the bottoms of both of these pieces and spread glue all around the servo. Be careful not to get the glue into the output of the servo. A small piece is applied to the inside of the servo. The servo should be flush against the bottom. A piece of tape can help support it until the glue sets. The same that is done for the front will be able to do for the rear of the servo. The servo should be roughly flush with the top and flush with the bottom. Do the same with the other side and let the glue set. Once it has, you can finish shaping the foam with a knife. Make small notches in the fuselage to give clearance for the two servo leads. Glue the leads flat against the wing. Carbon strips will be inlaid into the elevons as well. The pieces will be 5 inches long, installed center of the elevon 0.3 inches away from the leading edge. The elevons will have a slit cut at the same length as the strips. Check for a dry fit and then glue into place. Be sure to tape both sides and that the strips are flush. The 2900 kV motor will now be mounted. Glue is trimmed away so that the mount area is flat. Use a precision screwdriver to mark the holes by pressing in to act as a center punch. This allows the drilling to be easier. Drill holes with the screws if available. If not, use smaller screws so you don't split the wood. Make sure that you mount the motor so the set screws are up and down. Use Loctite for these set screws before you fly. To prevent accidental breakage of the motor windings, glue the motor leads to the motor mount. If you are savvy with soldering, you can shorten the ESC leads. I use solder braid to wick away the solder, remove the excess wire, strip back, and resoldered. You can also recrimp the other end if you have the supplies and tools. This will reduce the weight and make the wiring less messy. To mount the ESC, a small cutout was made to give clearance for the voltage regulator, so the ESC will sit flat against the fuselage. Don't use water to glue into place. About a 2-inch strip of the hook side of the hook and loop tape is applied just behind the nose section. The elevons are secured with hinge tape. You can pre-cut strips about 1 inch long by making shallow cuts in the tape while it's on the roll. To mount the elevons, you will need to hold them tight against the tail at about a 45-degree angle away from where you're applying the tape. you apply the 3 strips on top and 2 to 3 strips on the bottom. The quality of the joint depends heavily on how tight you keep the elevon to the tail when applying the tape. Check for proper range of motion and that there is not too much slop. The control horns are installed next. The control horn should be in line with the servo. Cut 2 small pieces of foam about 1/4 by 1/2 inch. Sand the corners off of one side. The control horn should be placed against the leading edge of the carbon fiber strips directly in line with the servo horn. After checking for a dry fit, apply glue and place a small piece of foam we cut out underneath to give additional support. Make sure the horn is square and tape into place. Next, we will install the receiver. To save weight, the plastic case was removed from the receiver. Channel 1 goes to the left servo, Channel 2 goes to the right, and Channel 3 goes to the ESC. A small slit is cut into the fuselage for the receiver to sit in. Don't use water here for the glue. The receiver is glued into place. Now is a good time for connecting the leads. Tape to secure until the glue sets. Next, we will install the control linkage. The wire will be approximately 4.25 inches long. Grab one end of the wire about 1/4 inch back with the end of a sturdy pair of needle nose pliers and twist into a hard 90. Then continue to twist until it is a half Z shape. Squeeze gently to compress. The goal here is to make a tight fit to prevent slop, but not too tight that will cause it to bind. With this end inserted into the servo horn, it is then laid next to the control horn. Be sure the servo horn is perpendicular to the tail. With the elevon parallel with the tail, the pliers should grip the wire where the holes are in the horn. The same half Z bend is made. Make sure to bend parallel with the other bend, otherwise it will bind. Cut off the excess wire. Remove the servo horn and then loop the other end of the linkage into the control horn. Then reattach the servo horn. Turn on your radio and apply power to the receiver. Move the servo horn until the elevons are parallel with the tail with the radio controls in the center position and all trims set to neutral. Check for proper control operation and range of movement. Correct any bonding. You may have to remake your control linkage if you did it incorrectly. Once the servo horns are in the correct position, install the retaining screw to keep the horn from coming off. You will need to add a mix of elevator onto channel 1 and a mix of aileron for channel 2. With the control stick pulled up, both elevons should point up and down when the control stick is pushed down. With the left stick, the left elevon should be up and the right should be down, and vice versa. The plane can be test flown at this point. To make the cover, we will take 2-inch thick EPP foam sheets and cut about 12 inches long. To make the cover, we will take our 2-inch thick EPP foam sheet and cut it 12 inches long, and the same width as the fuselage. It will approximately be 1.5 inches high. The fuselage is shaped using these measurements shown to act as guides. It can of course be cut freehand. Find the highest point on the fuselage and make sure that the cover is at least 3/8 of an inch taller. The ideal tool to use for this is a foam cutter, but it can be shaped with a saw. Outline the profile using the measurements given and use the nose as a stencil for the front section. Use the layout points to draw the outline of the profile onto the foam. Use the nose section to trace out the nose profile. When cutting out the profile, use radiuses rather than hard corners. The rear section is tapered about 1/4 inch from both sides. At about 1/2 inch up, make a 45-degree chamfer on the sides, and then taper down to one end. The cheeks of the nose are done the same way. Cut away the inside to produce a cavity to provide clearance for the fuselage components. The cover should fit flush without being needed to be forced down. Magnets are used to hold the cover into place. 2 are glued in on the back side and 1 in the front. Copy paper is used to cut out and place over the screws. The paper is then wet and the excess soaked up with a paper towel. Tape is then applied to secure it in place. Once the glue is cured, the cover is placed onto the fuselage and the cover is pressed down at the magnets to leave an impression onto the fuselage. A tool can be used to deepen the impression for the magnets to fit flush. Be sure that you have the magnets on the right size so they attract their mating magnet rather than repel. It is important that these are glued in well or they will pull out of the foam. Be careful when pulling up on the tape, as it is possible to pull the paper or the magnets up with it. After the glue thoroughly dries, the cover should be installed and the craft shaken. The cover should not fall off. Now the plane is ready to fly.